Well, thanks for coming. My name is Dan Eckelkamp. I'm with Engineered Air Balance Commissioning Group out of the Houston area. Engineered Air Balance is a very technical company. There's a lot of really cool, really smart people, kind of like the people in this room that work there. This is not a super technical presentation. I am drawn to the technical because of being in commissioning, and it's a big part of all of our jobs as commissioning agents, but this particular presentation is kind of where my big interests are, which is the project team dynamics. How do we get these group of people in construction that historically, may or may not get along very well, and facilitate that group of cool people to get the owner what they need. So that's kind of where my interests lie. So if you're expecting charts with psychometrics and pump curves, check one of my coworkers. They're probably giving a talk on that right now. We're going to go over some of the challenges that have to do with phase jobs and what that does to the stereotypical commissioning process. So some of the challenges there are like boundaries don't match. An architectural boundary might not match the actual boundary of your system. We're going to go over some of those potential solutions to those. We're going to go over a case study of a building pressurization on a phased project that we recently had, and maybe go over a few strategies for maintaining some cleanliness in that case study environment. So when it comes to a project, you got a beginning and you got an end. Generally, in my mind, there must be something wrong with me. Every single time I get a new project, I think maybe if I work just hard enough, it's going to go just that smoothly. But maybe it's just an unfounded optimism, but that doesn't happen. But this is generally what is in the construction documents, right? But this is kind of generally what we end up with on a phased project. But without fail, I always think it's going to be the first graph, and I'm always surprised. There's something about me, I guess. But the point of this graph here, this little chart, is to show that the following: on a phased job, you really can only see one phase at a time. So you can see the phase you're in, so that you can't see past the current phase. So you're not going to be able to know everything that's, especially on a remodel project, what are you going to encounter on those phases? So you might encounter asbestos insulation here, and that's this first phase. You get into the second phase, and maybe you've found some ductwork and has a pneumatic tube running through it or something, and maybe somebody ran a sanitary drain pipe through the kitchen in the wrong spot, or now the users want you to be quiet between the hours of 5 a.m. and midnight. I hope that's not a problem. And then you get to the end. But the point of those were just to show you, hey, there's just to get you thinking. You don't know what you don't know. You don't know what's out there. So with that being said, if I took a poll in here, we'd probably all agree to this next logic. Would we rather have an unoccupied workspace to do all the job, our scope of work in? Yes, we would. But on a phased job, we don't have that luxury. So hence the presentation. So this will go a lot smoother since that's what we're talking about. So we'll go over an example a little bit later of some of this. Some of the common challenges on a phased job, whether it's a remodel or brand new phased, is a lot of the building systems don't adhere to the architectural boundaries of each phase. When we'll go over some examples of these, you might have a static pressure sensor that's going to be installed in a future phase, but you need that air to somehow be controllable previously before that next phase is there. You might have some software that gets updated in subsequent phases. that sort of negates the testing that you just did. It can be a challenge to do buildings that have pressure relationships until all your phases are done. And this one was kind of new to me, but we'll go explore this a little bit more on long duration projects. I've got one right now that's on its 6th year, and we still haven't really gotten started with testing. We've had a lot of turnover in the project team, so there's some challenges that come with that specific one too. So that's kind of some highlights of what some of the challenges are. Some of the questions that you could ask of the occupants of the team, how do we keep your facility, if it's operational, might be, how can you handle outages? What does that do to you? What does that do to your operational requirements? Do you operate 24/7? Is there any time at all that we can have your facility? Let's work out those hours. What kind of disruptions can your particular space accept? You're going to lose power at some point. What do we need to put in place to make, minimize the impacts of that? And our pressurization requirements, are they a concern? Are there temperature or humidity requirements that can be maintained? That's just some of the questions to maybe get the wheels rolling as you're trying to facilitate the project team. So the first one, here's a typical 3-phase project. You've got phase 1, 2, and 3, so yellow's phase 1. What I wanted to show with this is, so you've got phase 1 here, and it has ductwork that goes into phase 2, served by, so you might have a 2/3 static pressure sensor that's going to be located somewhere over here, but yet you need to have this particular area running. You have to kind of discuss a plan for how you're going to control static pressure in those phases leading up to when that is finally installed. We'll go through that a little bit more. Now here between phase 2 and phase 3, you've got some hydronic piping. What do we do? How do we account for that? Did the engineer of record, did they come up with, oh, hey, by the way, put a bypass until you're in there? Or we'll have to deal with it. How do we deal with that supply and return piping in that area? These are just questions to go over. Here's an example of some lighting challenges on another phase project. This is actually this project had 26 phases, but I simplified it into 3 because I didn't feel like drawing 26. So what we have here is there's some lighting circuits that cross phases. A future phase is connected to the circuits in the previous phase. So at the minimum, you're going to have some kind of outage to deal with there. How are we going to test that in an occupied area once we finally get the circuits connected? These are some of the challenges. This one has more to do with lighting control. We've got an occupancy sensor here in this phase, but it controls this previous phase here. This actually happened. So how are we going to get these lights to operate with this occupancy sensor that's not even slated to be installed yet? How are we going to control those lights up until that next installation? So we kind of covered some of the architectural boundaries and what are the challenges there. This particular example has to do with software challenges. This is a particular building that had a very, very much out of code compliant fire alarm system. And so the project scope looked really simple on paper. Hey, it's an occupied building, but they've been out of code compliance. The authority having jurisdiction happens to actually be the owner in this case. So they had these 6 zones that they're going to take the fire smoke dampers and rewire them all, take them off the building automation, and have them be controlled by the fire alarm system. We're going to basically test it after each phase. So this is all weekend work. So they basically come in on a weekend, rewire all the dampers in zone A, and then they'd sort of pre-test that one area with the software that's in place. And then on the subsequent weekend, they do the next round, test it, and so on and so forth until they finished. So, interesting thing here is that took 5 years to come up with that plan. Still waiting to start. It's a lot of general conditions. So interestingly, what they came up with was, yeah, they'll take my test, our test, and use it and pre-test zone A and then B and C after each one. But if a lot of us being commissioning agents, you would be well within your right to ask the following question. Well, what happens, Dan, when I test A and it's all great, but the next weekend I come in and I do B? Well, what about the software changes I put into that same panel that A is in, and now I'm putting B kind of meshed in there between it? Doesn't that negate the testing of A? I would agree. That would actually, you should technically test A, then test A and B, then test A, B, and C, all the way to F. They decided not to do it that way. They decided, hey, we're already out of code compliance. We'll just test it at the end. It may or may not have been influenced by the fact that the authority having jurisdiction was the owner, and all of this was weekend work, and they didn't want to come in 7 times and said they just wanted to come in 1 time on a weekend with me. So that may or may not have been a factor. That previous project, like I kind of mentioned, took a long time to come up with that, what looked very simple with puzzle pieces. It took a lot of years just of how do we get this operational hospital up to code. During that course of that time, we had 5 project managers roll through. And this is something I had not encountered before, but on such a long-term project, what we had to do is each time we got a new project manager, we had to sell that new PM on everything that their predecessor had already agreed to. This is how we're going to test it. We had to go through that iteration for 4 iterations. It was an interesting experience. I hadn't encountered that before, so it was enlightening. This is an example of a project I have right now. It's actually still ongoing. Pardon my drawing, the construction equipment is not to scale. But the gist of it was, it's a career and technical center kind of in the Texas area. This was not originally a phased job. It was all supposed to be stereotypical, beginning, middle, end. But I kind of came in one day to one of my very early commissioning meetings to try to get them rolling with their, pre-functional checklists and all the documentation and go team go. I'm going to the trailer and I look at, there's this big section, the green section. There's no activity at all. There's nothing but dirt over there, and the rest of the building's coming straight up. Being somewhat familiar with the documents, I said, what's going on over there? And the GC's like, yeah, about that. It's fine. We were doing some dirt work over there for the foundations, and we uncovered human remains. I was like, oh, you did. So that was a shock. And I'm not making this up. That's exactly what happened. The GC's original intent was, okay, it's just fine. It's going to be a slight delay. That part of the building will lag behind the rest of the building. But the Texas Historical Commission got involved, brought out some archaeologists. These turned out to be grave sites. It wasn't just mercifully, it wasn't some mass burial site. It was just forgotten about cemetery, right on the building footprint. And so what they determined was there was 95 graves, all very orderly, in this particular spot. And as bad as everyone would think finding human remains in a cemetery in your building would be, it gets way worse, if that's even possible, but it is. It turns out these grave sites dated to around 1910. These were very, very likely freed slaves who were forced to work in a convict leasing program. So it's got great historical significance and lots of bad juju all around it. Um, so what ended up happening is instead of our building ending there, we now have the Career and Technical Center and Memorial Cemetery, which luckily for me, the engineering team is going to issue new documents, and they're still waiting on them, that show all the equipment that was going to be over here, is now deleted, obviously, because it doesn't exist. So they're going to issue me some new drawings, but the point of bringing that up is even on a brand new project, you don't know what you don't know. You might find some very unexpected conditions, and you might end up with a phase job. So, and I know the question on everyone's mind, and I'll answer it, is, Dan, will there be any nighttime testing on this job? And the answer is very much no. My team has told me they're packing up about 2:30 every day. There's only 5 or 6 hours of daylight left. It's time to go. So that's some of the challenges of the jobs that have phased. Now, some of the, I wanted to go over a couple of potential solutions for some of those things. But the point is I think our job as commissioning agents isn't necessarily to have the actual answer, but it's to assist in facilitating getting the team to come up with what the right answer is, rather than pretending we can always save the day. It's at least my thoughts on it. I also don't have all the answers to everything. I think if we polled the people in here on what would the solution be to any particular issue, you might have lots of different answers to the same problem. So you can, when you have a phased job, I mean, it's all about time, right? You can plan for a longer time frame, especially in the remodel sector. Expect there to be, a slight increase in scope, potentially, some scope changes. Account for the unexpected. One of the biggest points I'm trying to convey here is keeping the stakeholders invested and engaged in this process is key. You can just, I'll put it this way, it's been my experience that if you have the stakeholders, say in the laboratory remodel I went over with the 26 phases, giving them a voice in the whole process of the remodel, keeping them involved in the actual commissioning meetings, et cetera, is probably better than not, because if you give them a voice and you let them be heard, they're going to be a lot happier, because they're still going to be heard. They're just going to go around you to the project executives, et cetera. So that's my thoughts on that. You can counteract those issues with just a whole bunch of routine meetings, have a single point of contact. Phase jobs in general are tricky because you have those broken up systems. So it's crucial that we have a functional testing matrix that says here's everything we're going to test in which phases and in which parts and pieces, and utilizing that and sharing that with all the stakeholders it just keeps everybody on the same page. Let's see. We're about to transition to another part here, but most people, I imagine, have seen this device, the ball on the wall pressure relationships thing. I just wanted to point out that during that 26-phase sterile processing department remodel, obviously a sterile processing department has a whole bunch of pressure relationships between, maintaining positive rooms to keep things clean, et cetera. So there were a lot of temporary partitions that went up in there, and they had to maintain the pressures because it was an active, ongoing department. So I'm not Russian, but the Russians have a saying that the best is the enemy of good enough. And we could very well have gotten the controls contractor to put in, a temporary BAS network with lots of sensors and room pressure monitors in all of these spaces. But given that it was such a fast-moving project and the facility was operating 24/7, in this particular instance, putting these ball in the walls in some of these temporary partitions where it was positive on one side and negative on the other gave the users of the space an immediate visual indicator that they were used to looking at already. So they used these as their means of knowing, hey, is my room doing what my room is supposed to be doing, the very room that I'm in, creating this medicine for this patient. And what moves faster than the building automation network is a sterile processing department manager calling someone on the phone when they see something wrong. So anyway, sometimes the simplest solution works better. So this part of the presentation is actually what I was originally asked to talk on. Some of you all might know the president of our company, Galen Richardson, of Engineered Air Balance. So I walked into the office one day and I made the mistake of making eye contact with him. And he said, Dan, how'd you like to present your CXE paper at the next presentation in Orlando? And I said something like, okay. And I think my body language said something like, I'd rather be waterboarded, Galen. But here we go. This is actually the part he thought I was going to be talking on. But we had to add a little bit more content because this was just a short little paper, and this is an interesting one. So this is my phase job example. What we have is just a 4-story building with 7 air handlers in the and level 4, excuse me. And the thing about these is they have a common supply header. They're all connected to it, and they all share a common return plenum. Now, backing up a step, the ideal process and the way the specifications read is give me an entire building, complete its construction. Nobody's living there yet. No one's inside. The test and balance company has completed all of their work. And then commissioning agents come in and functionally test our stuff after all that's awesome. Then everybody moves in. That's what we would want. This is how the specifications always read. Well, that's not what we get on phase jobs. So that was really just the point of that slide. So hence the discussion. This building was not designed to be a phased turnover job in any way, shape, or form. You have common headers on supply and return. But after the building was already designed and largely complete, the owner came to the team and said, oh, by the way, we want to turn this over to us by floor. And that got fun. So they wanted first, give me level 1, then 3, then 4, and then 2. It's like, oh, okay. Oh, no, by the way, level 2 is a lease space for one of our other clients, and that's going to lag the rest of the construction by about 6 months. Okay, so you're going to have level 1 built with nobody living there yet. You're going to somehow do level 1 tab magically, and you're going to test level 1. And they're all going to move in. That's level 1. And the next order is do that same thing on level 3, and then 4, and then back to 2. Well, we had to come up with some ideas, so we start chit-chatting in one of the commissioning meetings that turned into let's just call it an all-day meeting. I guess it's more of a work session than a meeting. The first idea was, hey, can we, since everything's dirty, can we just close all the return dampers and just feed the whole place with supply so that none of the return ducts would be open, and we can get through tab this way, at least get air everywhere. Maybe we can feed what would have come through the return to those air handler units from these two outside air handler units that feed them. Can that work? Can we do that? This is probably the only math in the whole presentation, which was, each air handler does 26,000 CFM. It's a total of 182. My PTOAs could only supply me 60,000. So what that meant is I'm short about 122,000 CFM to feed the floors, which is fine, except, it's not great for your building to be overpressurized by, 122,000 CFM. And it's funny to put that picture up there, but I realize that we would probably have tripped on low static, but it's more fun to think about this way. So that was scrapped. So maybe here's the next idea. Maybe we isolate level 2, 3, and 4 completely and just send all the air to level 1. And that way we get it clean first, give all the air to level 1, don't give air to the other floors. Well, the GC was like, nice try, guys, but we kind of need that air to dry everything out. So that's not going to work. Come up with something else. Okay, good point. I thought we were onto something, but so this is what we actually ended up doing, was third time's the charm. Let's close the return air dampers on 2, 3, and 4 at the riser. Isolate the return on those floors. Open the stairwell doors on those floors, and let that be the path for the return air. While in that way, that gives you all of the conditioned air that you need to those floors, but you're still maintaining the integrity of your ductwork at the time. And so what we did was, the team did, wasn't me, as they put the temporary filter media over the doors. You've probably seen this before, where you keep the door open, it's wired open, all the stairwell paths are open, and lets the air go into each return as you need it. And that worked pretty well. So the idea would be, once the test and balance scope of level 1's done and level 4 is ready for balancing, then you do the same thing, to level 3. You'd close that stairwell door on 3 and supply it from, open the return path on that floor. And then you do the same thing for the other floor. The only hiccup to that plan was the owner mentioned, oh, by the way, the level 2 isn't going to be remotely clean. We're still designing it. It's going to be lagging for 6 months down the road. So in order to get air to that floor and not have it oddly pressurized, what they did was they asked the engineer of record, hey, can you design a special return air plenum filter adapter to that particular plenum for level 2, to where we can open up that floor return, but it'll all be filtered there, and we'll just kind of monitor it. So that was what they ended up doing. But if we have 7 air handlers, but none of them have had their test and balance performed 100%, and I can't do 100% of my testing until they're technically done, how do I give the owner a safe and reliable, in so much as is possible, building to them when they do occupy those floors? So what we did is we came up with the following, which was, as soon as the return air door for that particular air handler was closed, because we needed more and more static and for opening up more and more floors, our team would come in and after it was tested and balances, we'd check that particular unit for safety's general functionality. Couldn't do capacities technically yet. We'd have to revisit that later. And as more and more doors were closed on each unit, we would test them in turn. So that would give you some assurance that we've got some reliability because we've tested the sequence of operations on it. It's not the perfect way to do it. And then down the road, once all the returns for all floors and all areas are good, test and balance can be completed. And then we'll come back in and test the entire system, drive everything to max, drive everything to min, and go from there. So that's generally what we ended up doing. So, and I really flew through this presentation. So these are the objectives we just kind of went over. That's kind of what I had for you. But I am open to any questions or comments at this time. If anyone had anything. Yes, ma'am. Yes, in a word, the question was, given that some of the floors were going to be occupied and you had paths of egress concerns, is it cool to still leave the stairwell doors open on the other floors? In a word, yes, that was a concern. This particular job was also, the owner was the authority having jurisdiction. So they could kind of say, yeah, we're cool with that. And by the way, the general contractor, you're still on site. You technically owe fire watch, yada, yada, yada. So that's kind of how they got around that. It was a good question, though. Yes, sir.
Question on how you, common issue I run into when you have, say, air handlers that are being phased and you've got supply return fan and minimum outside air requirements, especially in like healthcare type situations where, say, the first phase is fairly minimal, maybe 35% of the total air handler capacity. I run into the issue where the unit trying to maintain its outside air requirements, it pushes the return air, the return fan down to its minimum on the VFD, and it can't get lower than that, so it's not actually making its return air or outside air, minimum outside air requirements, because the return fan can't back down any further than that. So commonly what I've finally found that worked pretty well is they just put in like a temporary bypass in so they can move more air, but I just didn't know if that's something you run into.
That's a good question. I haven't run into that personally. I have seen similar stuff on water for chillers where you don't have any load in the building and you might have multiple chillers, but you're down on one chiller and it just, you're gonna have to give it some sort of minimum flow to basically do a similar kind of a logic thing. We're running into that too, but that's a good point. Thanks for bringing that up. Yes?
Yeah, you said you did like essentially a prelim test for each air handler and then final testing at the end. Was that like a change order to add that to your scope?
Yes.
Or how did you handle that financially?
Sure. The question was, given that we're basically testing these units twice, or maybe 1.5 times, how do we handle that from a financial perspective? Yes, we definitely got a change order for it. I will tell you, we're actually still out there trying to finish that last portion. Building's limping along. I think if we all had to, we would probably agree this was not the way to do a building. If you wanted it phase turnover, you needed to account for that in the design. So we had to kind of collaborate this particular solution. It's not how I would have chosen to do it whatsoever. It was basically a rather uncommissioned building by the time it got to the end, and a lot left over to keep doing. And then all of your parties are much less interested in continuing on, given that they're done because it's occupied. So it was, that in and of itself was a challenge for sure. Anybody got anything else? Well, y'all been super cool. Thanks for coming. I appreciate it.